What if I told you that we're on the brink of chatting with the stars, not just gazing at them? No, this isn't a sci-fi plot, it's real science in the making. Stick around as we unravel the incredible plan to send tiny spacecraft to Proxima Centauri, our closest star neighbor, and how this could revolutionize space exploration forever. Let's first look at the research team. Have you ever wondered who's behind the mind-blowing ideas that could change how we explore space? Meet the Initiative for Interstellar Studies, or I4IS for short. This group of smart folks is working on something that sounds like it's straight out of a sci-fi movie. They recently published a paper that talks about sending tiny spacecraft all the way to Proxima Centauri, our closest star neighbor. Leading the team is T. Marshall Eubanks, the principal investigator of swarming Proxima Centauri, chief scientist at Space Initiatives Inc., and the CEO of Asteroid Initiatives. Alongside him is Paul Blaise, an electrical engineer at Space Initiatives Inc. Andreas Hein is a professor at Luxembourg University, and he's the executive director of I4IS. So this is the dream team that's working on a plan to chat with the stars. The mission is a collaborative effort between Breakthrough Starshot and I4IS US. Now that you know who's behind this groundbreaking work, let's talk about what they're actually planning to do. Imagine sending not just one but a whole swarm of tiny spacecraft into space. We're talking about spacecraft that weigh just a few grams each. The goal? To reach Proxima Centauri, the star closest to us, and keep in touch with Earth while they're at it. So how does this work? They're joined by Adam Hibbard, a researcher who's all about exploring new worlds, and Robert G. Kennedy III, the president of the I4IS's US affiliate. These mini spacecraft will be equipped with something called lightsails. These are super thin reflective sails that catch laser beams shot from Earth. It's these laser beams that will give the spacecraft the push they need to speed up and head toward Proxima Centauri. But here's the cool part. The same lasers that help the spacecraft speed up will also be used for communication. That's right, the spacecraft will use these lasers to send messages back to Earth. It's like using the same road for a round trip, only this road is made of laser beams. This way, even when they're millions of miles away, these spacecraft can still send us updates and data. It's a two-in-one deal that makes this mission not just possible, but super efficient. So you might be wondering, what makes these tiny spacecraft so special? First off, they are incredibly light. We're talking about spacecraft that weigh as much as a paperclip. But don't let their size fool you. These little guys are packed with advanced tech. Now let's talk about laser sails. These aren't your regular sails, they're ultra thin and super reflective. When a high power laser from Earth hits these sails, it gives the spacecraft a massive speed boost. Think of it like a jet ski riding a powerful wave, but in this case the wave is made of light. The goal is to get these spacecraft moving really fast, almost as fast as light itself. And FYI, that's about 186,282 miles per second. Achieving such speeds means these spacecraft could reach Proxima Centauri in just a few decades. That's way quicker than any spaceship we've ever built. So it's the combo of these lightweight spacecraft and their laser sails that make this mission so groundbreaking. They're small but mighty, and they're going to help us explore stars like never before. Every great plan has its hurdles, and this mission is no exception. One big challenge is how to protect these tiny spacecraft from particles in space. You see, when you're zooming through space at almost the speed of light, even a tiny speck of dust can cause big problems. It's like driving a car really fast and hitting a pebble. That pebble can do some serious damage. Another challenge is communication. We're talking about sending and receiving messages over insanely long distances. That requires a lot of data and a strong signal, which is tough to manage when your spacecraft is the size of a paperclip. So how does the swarm idea help? Well, for starters, having a bunch of spacecraft mean that if a few get damaged, the mission can still go on. It's like having backup players on a soccer team. As for communication, the swarm can work together to send data back to Earth. Think of it like a choir. One voice might be soft, but when everyone sings together, the sound carries far. In short, the swarm acts like a team. They cover for each other's weaknesses and combine their strengths, making the mission more doable and efficient. Now, how do we actually get them to Proxima Centauri? The plan is to launch hundreds of these probes, one after the other, like a string of high-tech pearls shooting into space. But it's not just a random launch, it's carefully timed. The idea is to get these spacecraft to form a swarm as they travel. They'll be launched with slight differences in speed so that over time they come together in a specific formation. It's a bit like organizing dancers on a stage. Each one knows their spot and how to get there. Now you might be wondering, how do we keep track of all these probes? The answer is lasers. Again, the same lasers that launched them will keep tabs on them. These lasers will also help sync the internal clocks of the probes, making sure they're all on the same page, or rather, the same second. And to keep this formation steady, the spacecraft will make tiny adjustments as they go. They'll use the natural drag from particles in space to tweak their positions, like a boat using the current to stay on course. So we've got these spacecraft flying through space, but how do they stay powered for such a long journey? The answer is something called beta-voltaic isotopic application. Sounds fancy, right? But it's actually pretty simple. It's a type of battery that uses radioactive material to generate electricity. These batteries are small but super long-lasting. They can keep the spacecraft powered up for decades. Now, why is this important? Well, staying powered up is crucial for communication. These spacecraft will use something called optical communications to talk to us back on Earth. That's a fancy way of saying they'll use light to send messages. And guess what? Light doesn't need a lot of power to travel great distances. So these beta-voltaic batteries make sure the spacecraft have enough juice to keep sending us updates, even from way out in space. The best part is, because these batteries last so long, the spacecraft can keep talking to us for decades. That means we could get real-time updates from near another star. It's like having a long-distance pen pal, but in space. While the focus has been on Proxima Centauri, the technology we're discussing has applications that stretch far beyond this single mission. The technology could potentially reach out as far as Sirius, which is about 50 years away with the planned breakthrough technology. Let's break it down. The same principles that make a mission to Proxima Centauri possible could be applied to other star systems. For example, Alpha Centauri and Sirius are also within reach. These missions could help us understand the composition of other stars, look for exoplanets, and even search for signs of life. Closer to home, these tiny spacecraft could revolutionize how we explore our own solar system. Imagine sending swarms to the outer planets like Jupiter and Saturn, or their intriguing moons like Europa and Titan. These missions could be launched more frequently and at a lower cost, providing a constant stream of data. The beta-voltaic isotope batteries and optical communication methods aren't just for long-haul trips to other stars. They could be used in satellites and probes within our solar system, offering longer mission lifetimes and better data transmission than ever before. One of the most exciting aspects is the multi-mission capability. A single launch could deploy multiple swarms, each programmed for different tasks. Some could be sent to gather data on cosmic phenomena like black holes or supernovae, while others could focus on resource mapping of asteroids. The swarm concept also opens up possibilities for international collaboration. Different countries could contribute different instruments or even entire mini spacecraft to a swarm, sharing the costs and the data. We're not just talking about a single mission to Proxima Centauri, we're talking about a technological leap that could open up a whole new era of space exploration, making the universe more accessible than ever before. This research is a game changer. It's not just about reaching Proxima Centauri, it's about redefining what's possible in space exploration and communication. From tiny spacecraft to laser sails, this mission packs a punch of innovation that could set the stage for the future of interstellar travel. But wait, there's more. If you're fascinated by the idea of cosmic communication, you won't want to miss our next video. We dive into the mysterious signals we've received from the galaxy, and let's just say they might be from our cosmic friends. Click right here to check it out and keep exploring the universe with us.